Let's turn now to implementing energy efficiency in building operations. There are 7 key steps to energy management in buildings. 1. Initiate an energy management program. 2. Determine efficiency targets. 3. Conduct energy assessments. 4. Identify energy savings opportunities. 5. Calculate costs and paybacks. 6. Implement the measures. And 7. Monitor performance. So step 1 is to initiate the energy management program. This step requires a clear indication that energy management is a priority. In this step, it is important to firstly develop a basic understanding of the existing energy situation in the building. We'll develop a more detailed energy assessment in later steps. Secondly, identify a core team that can be involved through the whole process, including developing a vision, implementing the energy management plan, overseeing efficiency improvements, and evaluation. And thirdly, define and set specific objectives that will guide the energy management program and be used to develop the plan, communicate that plan to a range of stakeholders, and motivate those stakeholders and staff. Step 2 is to set goals and determine the energy efficiency targets that the energy management program is intended to meet. It may take significant effort to do this and to ensure that appropriate targets and timelines are set. This step depends on understanding the energy use in the building, identifying the energy efficiency potential, and working to set effective targets through stakeholder engagement. Early on, to get the process started, leadership might set aspirational goals with advice from experts. These goals can help build into the next steps of the energy management plan. Step 3 is where we get more detailed information on the building and identify the steps that can be taken to achieve the aspirational targets set by the leadership and experts. This can be done with the help of a respected third-party auditor or by the energy management staff that is part of the core team for the energy management program. There are several tools that can be used to better assess the energy situation, such as an energy planning ledger. This is a basic information collection form that requests information on the building size, age, energy consumption, and building use patterns. Or questions for operations and maintenance staff. These are more technical questions about how the building is operated and about maintenance schedules and staff training. And thirdly, a walkthrough assessment checklist. This is a complete checklist of each of the technical energy-using components of the building: heating, cooling, fans, water heating, lighting, and other equipment, to document the operations and maintenance patterns for each. The information gained through the energy audit and assessment can be used in the next steps to identify opportunities for improvement in the operations and maintenance of the building and its components to improve the energy management of the building. Step 4 is to identify energy savings opportunities by using the data collected and conduct analysis across a range of options. A key to this step is to start with low-cost and no-cost energy sufficiency and energy efficiency measures. Next, it's important to make energy savings part of the culture of the organization. This means engaging stakeholders to gain feedback while at the same time building capacity to identify energy savings potential, to more effectively implement energy savings measures, and to build overall user acceptance throughout the program. The next 3 steps serve to look for energy savings opportunities from a systems approach and should be considered in order, one after the other. Firstly, retro-commissioning. This is a process to address maintenance and repair issues and changes in operation that can save energy. The goal is to get the systems to operate as they were intended to when they were initially designed and installed. Secondly, system improvements are undertaken to upgrade building components that impact the internal heat gains, electrical loads, and components within heating and cooling equipment. The purpose is to identify the potential for savings that can be achieved without fully replacing the heating and cooling equipment. Instead, the focus is on replacing components that impact overall energy efficiency. The other goal of this step is to reduce the heat gain in the buildings by increasing the efficiency of lighting, appliances, and other equipment, which will help reduce the size of the cooling equipment needed when looking at equipment replacement options. And thirdly, replacement options. The last step is to analyze full equipment replacement options to save energy. It is important to undertake this step after accounting for the potential savings available through retrocommissioning and building improvements. This will reduce the size of the equipment needed and improve cost-effectiveness of the replacement. Step 5 is to examine the cost-effectiveness of the measures identified in Step 4. There is a range of analytical approaches to examine the cost-effectiveness of different energy savings options. The approach will depend on the audience and the rigor of proof needed to gain approval to implement the efficiency measures under the Energy Management Plan. The most accurate analysis is also the most complicated. It is to examine the full range of benefits over the life cycle of the building efficiency measures. Life cycle analysis is the best analysis to use when working to understand the full benefits compared to other investments that could be made by the organization. Benefits are not limited to energy and cost savings, but might include factors such as health, safety, productivity, and other factors. The benefits of energy efficiency will be discussed in more detail later on in the course. Other types of analysis that could be applied more quickly include simple payback, internal rate of return, or IRR, abridged cost-benefit analysis, or net present value of the measures. Steps 6 and 7 are to implement the measures and then to monitor their performance. These are discussed together because to have an effective evaluation, the monitoring should account for the baseline situation prior to the measures being implemented, account for the costs and effort to implement the measures, and monitor performance after the measures are implemented. Similarly to the policy cycle, energy management systems should be considered as an ongoing cycle. The systems level thinking just discussed should be used to ensure continuous improvement of the energy management program, using the data and information collected to identify future energy savings